Hello everyone. Today let's solve the problem Moamen and Xor. So you can read the entire question here. They have clearly mentioned. You can read the entire question. Also, they have given the example here along with the input. So for this input, we have to get this desired output. So I'll just summarize the question for you so that it is easy to understand. So what the question says, just give me a second. So what the question says here, so problem summary, like I'm just summarizing the problem. So Moamen and Xor are playing a game involving an array of non-negative integers. So we have array of non-negative integers. So suppose I'll just consider 1, 2, 3 something. Array of non-negative integers for a given array of size n. So I'll just keep here n. So where each element is less than 2 to the power of k. They have said each element is less than 2 to the power of k. Also, Moamen wins if the bitwise end of all the elements is greater than or equal to bitwise OR. So Moamen only wins if the bitwise end is bitwise end of all the elements is greater than or equal to this one, greater than or equal to bitwise XOR elements. Bitwise XOR. I'll just give bitwise XOR. Moamen only wins if the bitwise AND is greater than or equal to bitwise XOR of all the elements. What is our main goal here? So till here, this is the question. What we have to find out, our main goal is to compute how many such arrays exists for the given n and k values. So how many such arrays exist, that's what we have to find out for the given n and k value. We have to output the result modulo 10 to the power of 9 plus 7. So we'll make use of the modulo usually so that the elements doesn't overflow. If we are dealing with the large numbers or if we are handling the large inputs, then only we'll make use of the modulo, right? So that the element doesn't overflow. So we have to output the result modulo 10 to the power of 9 plus 7. This is what the question. So mainly we have to compute how many arrays exist for the given n and k values. So I hope this problem is fine. I hope you understood this one. So next, let's go with the approach. So first step, as usual, we'll be going with the input handling. I'll just come here. First step is always input handling. So we'll be reading the input and we'll set the encoding to UTF-8 and other steps. We'll be doing this one, input handling. So while writing the code, you'll get to know input handling is same for most of the problems. As we are making use of the JavaScript or the Node, input handling is same for most of the problems. So after input handling, the second step or the core logic. So we'll be going with the dynamic programming for this particular problem. So when I say dynamic programming, why we are going with the dynamic programming? So that we can pre-compute the number of ways to construct arrays of size n. In the second step, we are pre-computing the, so I'll just give pre-compute. So we are pre-computing the number of ways to construct the arrays of size n. We are pre-computing the number of ways to construct the arrays of size n where result meets the certain conditions. We are making use of dynamic programming to handle the large values of n efficiently. So to handle the large values of the n efficiently, we are making use of the dynamic programming. So this is the reason mainly we are making use of DP. So also we are pre-computing the number of ways to construct the arrays of size n, right? Initially. So this is the step 2 here. After doing this, what we will do? We will handle odd and even cases. We have to handle the odd and even cases, right? Depending upon whether n is odd or n means the sequence is odd or even, the approach changes. For odd, the approach changes for even. So we have to use the pre-computed values to quickly compute results based on whether n is odd or even. So we have pre-computed the values. Based on that pre-computed values, we have to quickly compute the results based on whether n is odd or n is even. So pre-computing helps us in this way, right? So based on the pre-compute that we have done in the step 2, we have to quickly compute the result based on whether n is odd or n is even. This is third step. The final step is we'll be making use of modular arithmetic, right? Since why we are making use of the modular arithmetic? Since the results can be very large, we are making use of modulo, nothing but 10 to the power of 9 plus 7, the value. So to prevent the overflow, as I've said earlier, to prevent the overflow, we'll be making use of, or the results can be very large, we'll be making use of modulo, nothing but 10 to the power of 9 plus 7, the value, and to fit in within the problem constraints. Also, finally, the last step is to output the result. So we'll output the results. I'll just give output here. These are the steps. This is the approach that we will be using in this problem. So I'll just delete this one. Let me delete this one and start write the code so that we will understand this one better, right? So in this problem, instead of the type number, we'll be going with the big int to handle the large numbers, right? So initially we'll start with the this one. We'll ensure the code reads input and process it correctly. As usual, input handling. The first step is process standard input dot resume. So next, process standard input dot, we will set on encoding. We'll set this one to UTF-8. So this is first step. Next step is we'll set the input string to empty string. Also, we'll set the current line to 0. Next, we have to collect all the input data. We'll be making use of the event listener. I'll just give process stdin dot on. We have to get all the data, right? I'll mention data here. Let me consider input stdin. So here, after this, we'll be appending the input string to input stdin. I'll just give input string. We'll be appending this one to input stdin. So next, I'll copy the same thing and make the necessary changes. So what we'll do in the next step, basically, we have to process input data once all the inputs are received, right? So let me change this one to end. Let me double click, remove this one. So also here, we don't have to append anything. So I'll just remove this one plus. So also here, instead of stdin, this will be input string. To remove the white spaces, I'll make use of trim. To read every individual line of input, I'll just make use of split /n. Also, to remove the white spaces from all the lines of the input, I'll just make use of map string. I can just give string dot trim here. So this is fine till here. Next, we have to call the main function here. Right. So we have not written the main function yet. We'll be writing the main function in the future. After writing the main function, I'll just come here and call the main function. So let's leave the space there. We have to read the individual lines of individual input lines, right? Every line we have to read. So I'll just make use of the function read line. Here I'll give return input string current line. Let's increment the current line. First line, next the next line. After the next line, how many number of lines of input are there? We have to read each line. So I'll be making use of the current line. So this is fine. Next, after this, let's write the main function. To handle the core logic and we'll be writing the core logic or the main logic inside the main function. Just in simple terms, we are writing the main function to compute the result for each test case. So I'll just give function main. Within this, let me give let p equals 10n Let me make use of the exponentiation operator. This will 9n plus 7n. This is nothing but the modulo value, right? 10 to the power of 9 plus 7. So this is correct? Yeah. This is fine. We are just defining the modulo value as 10 to the power of 9 plus 7 over here in this line. Next, we'll define the maximum value for n. How can we define the maximum value for n? I'll just give max n. I'll just take the variable max n. Let me give this value, max n value. So we are just defining the maximum value for n, particular number. So next, we have to define the array to store the pre-computed values. As I have said in the approach that we are pre-computing, right? We are pre-computing the values. For that, we need to define the array. In my case, I'll just give dp equals new. Let's make use of begin this time. Big un array of max n. So this is fine. Next, first base case. What is the base case? We'll be setting dp of 0 to 1. So how can we write that? This is 1D array, right? So dp of 0, we can just set this one to 1, nothing but 1n, as we have considered begin. So here, let's pre-compute the values for the dp array. Nothing but we will iterate, right? So I'll just give let I equals 1n, I less than, again let's make use of the begin of max n. This I has to be capital, sorry. Begin of max n. Let's increment the I. Next, dp of number I with this one, dp of number I minus 1. So into 2 to the power of n. This one module 2 module t. So this is fine. Next step, we will read the number of test cases. So we have to read all the test cases, right? For that, I'll just make use of t or tc. I'll just give t again. So if we are making use of begin, we have to make use of begin everywhere. Or if we are making use of the number, we have to make use of number everywhere, right? So begin of, we are reading, we have to read every test case, right? So I'll just make use of the read line here. Next, let's iterate through each test cases. This one will be t equals, we'll start from 0, right? I less than individual test cases. Next, let's increment the t. In next case, I'll just use the destructuring operator. Again, we have to read, and if there are many numbers in the same line, then we are splitting and leaving the space between the numbers. And finally, we will map of, this time instead of number, I'll go with begin. So we are reading n and k for the each test case. Next, edge cases. We had seen the base case. Next, edge cases. If n is 0, then no valid arrays exist, right? So n should not be 0. If n is 0, then no valid arrays exist. How can we write? For conditions, I'll just make use of if n equals 0, n. Why we are writing 0 n? Because we are making use of the begin modular arithmetic, right? So that is the reason I have given 0 n. If n is 0, then no valid arrays exist. So I'll just directly make use of the console log. Console log inside the this one, within the string, I'll mention 0. Then let me give continue. This is one thing, and let h equals dp number of n minus 1n. So this is one thing. So we are getting the pre-computed value for n minus 1. That's what we are doing here in this step. So after doing this, what we will do, if n is odd, then we'll initialize the answer to 1. So for that, I'll just make use of the if condition. So this is easy. So n is odd means we'll just go with n module 2 equals 1. If n module 2, if this n is odd, so I have to give here, for everything I have to mention the n, right? And this is fine. Then we'll initialize the answer to 1. Let answer equals 1. Again, n we have to give. Then let's iterate through the each number. I'll just give let I equals 0. This has to be n again. I less than k. K itself we have to write n and k. Yeah, I. Let's increment the I. So let's compute the result for odd n and let's apply the modulo. So how can we compute the result for odd n? I'll give answer equals answer into h plus 1. H plus 1. I'll just add n for every number. Also, we'll apply the modulo. Mod. With answer mod p. Right? This is fine. Next, we have to print the result. So while printing the result, we'll be converting that one to the string. So for printing, I'll just make use of console log, and we are printing the answer, and this one we need in the form of string. So I'll just convert this one using toString built-in method. So else, if the number is even, this was if the number was odd. So n module 1, you can clearly see here. This if the number was odd. Here now we'll check if the number is even. Nothing but if n is even, then we'll initialize the answer to 0, not 1 this time. I'll just give let answer equals 0. This is fine. Also, let's initialize the array to store the intermediate results as well. Again, here also we have to make the to initialize the make use of begin by u, and let me make use of the 64-bit 64 array. Sorry, not bit. 64 array. Here, this will be number of k. So this is fun. What we are doing in this line, we are initializing the array to store the intermediate results. Next, let's go with the base case. So base case for a. Let's initialize a to 1. This is first step. Next, again, we'll get the pre-computed value for even. Even, right? Pre-computed value for n when it is even. So I'll just give let d equals dp of, or directly we can give, right? This time I'll just take here number of n. So this is fine. Next, let's compute the intermediate results for array a for all the values. Let's iterate now. Let I equals 1 I less than k. Yeah, I less. So a of number I, a of number I minus 1n. So this has to be into d module p. So this is fine. So next step, what I'll do, let's initialize. Yes, this is we are initializing the yes here. So I'll just give s equals 1. Let's call s equals 1. Then iterate again for let I equals 0. And n and k we have to write. So yeah, this is fine. Increment I. Answer equals answer plus what we are giving a
we have to mention this one everywhere. K minus I minus 1. I have to add n as well right here.
So what we are doing here, we are computing the result for even n, not the odd. Odd we have already done. We are just computing the result for even n. After computing the result for even n, we have to apply the modulo, right? Again, I'll just make use of the modulo. This one, p. Then we'll update yes, and then after updating the yes, then also we'll be applying the modulo, so that we'll get so that it doesn't overflow, right? Yes equals s into h minus 1 n. So let's update the s. Now let's apply the modulo, nothing but s modulo p. So this is fine. So after this step, what we will do, finally we'll add the final value yes to answer. This is easy. So I'll just give yes. Then again we'll be applying the modulo. So this one will be modulo equals p. Finally we have to print the result, right? Now we got the solution. Now we have to print the solution. For printing, I'll just make use of console log answer, and we need it in the form of string. So to convert this one to string, I'll just make use of toString built-in method. So here I'll give this one. This is fine. And somewhere I missed something. I don't know what I missed, but I missed something. It's module B here. So yeah, let's check. Yeah, I'll just call the main function over here. So this is it. Let's see. I'll just give the input here. Let me come here. So let me hit the run.
So reference errors we are getting, right? Line number 24, deep is for the new big array of maxim. Why we are getting reference error?
Line number 24. Just give me a second. So here I have just given big U int. Oh yeah, here 64 I have to mention, right? Sorry. Yep. Now let me run again.
One we are getting, what is this? Cannot make big int and other types use explicit conversion. Where line number 62, where is 62?
Just give me a second. 62. What happened? So what mistake I have done here is, let's come to line number 29. This one. So here, I had to close the flower braces here. So extra I have closed it here, I think. Just remove this braces here. One thing. And also, let me do one more thing. I'll just come here, line number 32. Here, this has to be t equals 0 and t less than t, right? So I have typed I instead of t. So this is one thing. This is one thing. Next, I'll just come here. This one has to be n. We are making use of the begin. So I have given, we have to give n everywhere. So here I forgot n. This is one thing. And the final one is here, line number 61. Here, this has to be answer plus yes into a of number k minus I minus 1n. So now this has to work properly. Let's check. I'll just hit the run button. So yeah, again, yes is not defined. Yes has to be capital, small, I think. Line number 61, right? This one, yeah. Yes is small. So let me hit the run button again. Now we are getting the output 5 to 1. What output we need to get? Yeah. The output has to be 5 to 1 itself. We are getting the correct output right now. So this is fine. What I'll do, just give me a second. So let me copy this one. I'll just come here. let me click on submit code. So let's wait for some time. So yeah, this is problem C. I'll just paste the code. Let me hit the submit. So let's wait for some time. So here you can see this is accepted, right? So the code works absolutely correct. I did some typos and also I missed something here. Finally, yes, into this has to be. And also bracket, I missed somewhere. This one here, one braces. I had to close this one here itself. Instead, I had closed here at the final. So these were the mistakes. So now the code works absolutely fine. So yeah, this is it. Thanks for watching, guys.